All right, welcome. Today we are diving headfirst into the world of robotics, and I mean we're really going to get our hands dirty. We're going to bring a machine to life, following the exact steps to wire up an autonomous smart car from scratch.
It's a pretty wild question, right? It sounds like something straight out of a movie. But the answer is way more hands-on, way more tangible, and honestly, a whole lot more fun than you might think. We're going to transform this collection of parts right here into a smart, self-driving vehicle. It's a journey from a bunch of inert components into an intelligent machine, and you know what? It all starts by giving it a heart.
Okay, let's get into it. Every living thing, every machine, it needs a source of power. For our car, that's the power distribution center. This is the first and, believe me, the most critical step, because without a stable power source, well, nothing else is going to work. So, this little board right here is the key to everything. It takes the raw 7.4 volts from the battery and does something really clever. It splits it. This creates a separate, super stable 5-volt supply. Now, why do we do that? Well, the powerful motors, they need the full 7.4 volts. But the delicate stuff, the brain and the sensors, they need a gentler, more stable power source. This is the foundation for everything that's coming next.
Following these 4 steps is absolutely key. We start with the main battery connection, then we use a voltage regulator to create that crucial 5-volt rail. And then we add capacitors. Now this is a bit of a pro move. It smooths out any electrical noise and gives our components clean, reliable power. Think of it like giving our car's heart a perfect, steady rhythm. With the heart beating strong, it's time to connect the muscles. Yep, the motor that's actually going to make this car move. This is where all that potential energy becomes kinetic.
This motor drive module is essential. It's basically the bridge that takes the high voltage power from our 7.4 volt rail and delivers it to the motor in a really controlled way. You can almost think of it as the car's transmission system. And just like that, with those connections made, power is now flowing directly to the motor. We've given our car the raw physical ability to move. Now, it can't think for itself yet, not even close, but it is officially ready to run.
Now that the muscles have power, it's time to build the nervous system. We need to wake up all the sensors and controls that are eventually going to give this car its awareness of the world.
We're about to energize a whole suite of components here. The infrared and color sensors, they're going to become its eyes, the servo is its steering, and of course the microcontroller, the brain itself. All of these are going to run on that nice stable 5-volt power rail we created just a minute ago.
And the process is actually surprisingly simple. It's a universal rule for this part of the build. Every component's power pin connects to the 5-volt rail, and every ground pin connects to the common ground. And just like that, the entire power grid is complete. Every part of the car is now energized and just waiting for instructions. Now for the magic. We have a body with a beating heart and energized muscles. So it's time to connect everything to the brain of the operation, the microcontroller. This is the moment where we grant it consciousness.
For this build, we're using the Xiao NRF528040 from Seed Studio. Its tiny size is perfect for keeping the car light, and the built-in Bluetooth is a fantastic little bonus for any future upgrades. This little chip is about to become the command center for our entire vehicle.
So this is the first command channel we're creating. By connecting these 2 pins, we give the brain a direct line to the motor drive. It can now send signals to move forward, backward, or stop. The muscles are now officially controlled by the brain.
Now for the steering. We connect the servo signal wire to the brain. And just like that, we have power steering. The brain can now send these precise signals to the servo, telling the wheels exactly how far to turn left or right. It now has full control over the car's direction.
Okay, this is such a cool choose-your-own-adventure moment in the build. At this point, you have a fully functional, remote-controllable car. You could stop right here and have a ton of fun. But we're here to build a self-driving genius, right? So for those of you sticking around, let's give this car some senses.
So, to drive itself, our car needs to perceive the world around it. We're going to give it vision by installing a set of infrared sensors.
Mounting these 3 infrared sensors on the front is what's going to give the car its primary guidance system. They're designed to detect a line on the ground, which will allow the car to follow a predefined path all by itself.
By connecting these 3 sensors to 3 separate digital pins, the brain can now process their input individually. It can tell if it's perfectly centered on the line or if it's starting to drift to the left or right, and then it can correct its steering accordingly. Pretty cool. For the next level of intelligence, we're adding a color sensor. This is a huge upgrade. It allows the car to detect specific colors, which means we can use them to signal things, like a sharp turn, a stop sign, or even the finish line of a race. These last two connections use a communication protocol called I2C. It's just a simple but really powerful way for components to talk to each other. By wiring up the data line, SDA, and the clock line, SCL, we've given the brain a rich, continuous stream of color data. With this final sense installed, our car has all the hardware it needs to become truly autonomous.
And just look at that. We've done it. From a pile of parts, we have successfully connected the heart, the muscles, the nervous system, the brain, and the senses. This isn't just a collection of wires anymore. It's a completely integrated system, a body that's ready for a mind. We've actually brought it to life.
The hardware is done, but the journey is just beginning. The physical form is complete, but its mind is a blank slate. The only limit now is the code you write and the challenges you set for it. So the question isn't just what can it do, it's what will you teach it to do.